Wind erosion is a devastating problem in western New South Wales, burying fences and roads and sandblasting crops. This results in substantial damage, which equals a cost to both the farmer and the community. We all know what even the smallest loss means in these economic times. Wind erosion is influenced by two main factors: soil type and the amount of vegetation cover. Let's discuss each in a little more detail. Firstly, soil type. The lighter or sandier soils are particularly susceptible to erosion and hence require special attention. Wind speeds as low as 20 kilometres an hour at ground level will result in significant amounts of soil movement. It is the fine particles in soil which bind the nutrients and the water necessary for plant growth. These same particles are the first removed by wind. This is the dust you see in the air. Thus even the slightest amount of wind erosion will rob the soil and you, the farmer, of nutrients and water which should have been available to your crops and pastures. Sand hills are particularly prone to wind erosion because their elevation exposes them to greater amounts of wind energy. A vegetation cover protects the soil from erosion by providing a barrier between the wind and the soil surface. When this vegetation layer is removed, the exposed soil is very vulnerable to erosive forces. So how can trees be used to prevent soil erosion? There are two main ways. Firstly, by decreasing the wind velocity at ground level. That is, by the establishment of windbreaks which protect the soil for quite some distance on their leeward side. Or secondly, by establishing a woodlot which protects the immediate ground on which it is planted. Let's look at windbreaks first. When establishing tree windbreaks on any property, there are a number of important things to consider. The first is orientation, and this is most important. A windbreak should run perpendicular to the prevailing winds. In western New South Wales, these are generally from a southwesterly direction. If possible, a windbreak should also run it perpendicular to the most severe winds. This generally gives us an L-shaped windbreak. The second consideration is design. A windbreak needs to be at least 2 rows wide to be effective, with 3 or 4 rows usually being ideal. The exact number of rows you choose will largely depend on the form of the trees to be planted, that is, their height, crown size and crown depth. A windbreak will effectively reduce wind speeds over a distance of 20 times their height. A 5-metre high windbreak effectively reduces a 40 km/h wind to at least 25 km/h over a distance of about 100 metres. This represents an average reduction of at least 40% in wind speed over this distance. A 10-metre high windbreak will reduce the wind speed by this same amount over a distance of at least 200 metres. Thus, by increasing our windbreak height from 5 metres to 10 metres, we increase the effectively protected area from 100 metres to 200 metres. The higher the windbreak, the greater the distance it protects. The length of a windbreak is also important. As a rule of thumb, a windbreak should be at least 12 times as long as its mature height in order to maximise its effectiveness. The last aspect of windbreak design to consider is wind penetrability. A windbreak of 40% open provides a much more useful shelter than a dense belt of trees. This is not to say that big gaping holes in windbreaks are useful. Rather, the opposite applies, with these spaces actually focusing wind energy, creating a tunnel effect, which may even increase areas of wind erosion. If you must have a gap in a windbreak, such as a stock entrance, this should be designed to minimise deleterious effects, such as the case in this windbreak. The gateway is tunnel-shaped to distribute the wind focusing effect over a wider area and hence decrease its intensity. The entrance is also orientated such that it is not in line with the prevailing winds, but rather at an angle to it. Species selection is the third consideration, and perhaps the most important. No one wants to replant windbreaks because of poor initial species selection. Factors such as soil type, frost prevalence, frequency of waterlogging, growth rate, and longevity of the species should all be considered before the final selection is made. Adequate preparation is the fourth undertaking when planting tree windbreaks. Permanent fencing to prevent stock and rabbits getting in is a must. Deep ripping up to 12 months before planting can greatly enhance vertical root movement and hence seedling growth. Control of weeds by the use of herbicides or weed control matting for the 2 years following planting will greatly increase your planting successes. So recapping on what we have just said, the most important considerations when planting a windbreak are 1. Orientation, 2. Design, 3. Species selection, and 4. Adequate preparation. Now let's look at woodlots and erosion affected areas. In areas very badly affected by soil erosion, replanting with trees or shrubs may be the only solution to the problem. This may mean taking that area, say the upper slopes of a sandhill, out of production altogether in order to stabilise it with trees. The incorporation of trees into a revegetation program gives long-lasting protection to both the soil and other vegetation such as shrubs and grasses. Mr. Jeff Langley, a potato grower from Barooga in southern New South Wales, seen here talking to District Soil Conservationist at Hay, Mr. Julian Pryor, has taken steps to protect the sandhill on which he grows potatoes by planting tree windbreaks. Potatoes have high nutrient and water needs, and Jeff has found that wind erosion can cost him money through the loss of valuable soil fines and the sandblasting of young crops. Sandhills do present particular problems when it comes to establishing trees. Water and nutrients are easily leached through the soil profile, and as such, water stress often kills many seedlings. Another source of moisture loss is surface evaporation. Evaporation can be reduced by covering the soil around the plant with plastic, newspaper, hessian or mulch. The elimination of weeds from 1 metre around the growing plants is also very important, as these compete for the limited water and nutrients available. The addition of a slow-release fertiliser, particularly one high in nitrogen, may also be necessary at the time of planting. When planting with trees, there are 2 very important points to consider. Firstly, plan carefully. Ensure appropriate windbreak design and undertake tree establishment at the optimum planting time and in a way which will produce the best results for you. As well, make sure all tree plantings complement your overall farm plan. Aerial farm layout photos available from your nearest Department of Lands office are excellent for visually mapping out tree planting in relation to farm fixtures and practices. Secondly, set realistic planting goals. If you have time to plant 100 trees, then only plant 100. Success will come more readily if you start in a small way and increase your plantings each year as your knowledge and expertise increases. Although you may think only small amounts of soil are lost to wind erosion, consider this. The movement of only 1 millimetre of soil per year equals a soil loss of 10 to 15 tonnes per hectare, a rate far greater than that at which most Australian soils are formed. So what do you prefer? This sort of landscape or this? For further information on windbreak or tree establishment, please contact your nearest office of the Soil Conservation Service, Department of Agriculture or New South Wales Forestry Commission.